What's up? What's up? What's up? It's your boy, the network. Today's topic is section 3.26b, Bravo, OSPF LSA types. This also says here area type. We're not going to cover area types. We're going to separate this in two parts. So today we're just going to cover the LSA types. Part 2 is going to cover the area types. This is a topic in the CCNP route exam code 300-101, version 2.0. Let's go ahead and take a look at the exam blueprint, take a look at, see where we came from, where we're headed. Hashtag lab every day. As you can see, I'm still here in beautiful Miami, Florida. It's like it's really humid right now, but nonetheless, it's beautiful weather. You can see this is exam blueprint implementing Cisco IP routing, exam code 300-101. Again, this exam expires February 23rd, 2020. After that, you're going to take the new version, which is called CCNP Enterprise. That starts on February 24th, 2020. We just wrapped up the section. Yeah, we did the network types right here. Right now, we're going to cover the LSA types. After that, we're going to move on to area types. So, what are LSAs? LSA is a link state advertisement. Remember, we talked about the different OSPF packets, right? An LSA is it's an advertisement that's given to OSPF, neighboring OSPF routers to let them know about OSPF routes. Those are collected and put into what's called an LSDB, a link state database. That is managed by the designated router in the network, if there is one, and he will synchronize it with every router that's in the OSPF network. Now, there's several LSA types. Let's go ahead and take a look at this slide here. Now, there are about 11 LSA types. Yes, there's about 11 of them. However, for the CCNP route exam, we only need to cover, I don't know what that is. Oh, that's the sprinklers. We need to cover only 6 types. As you can see, I've put strike-throughs for the ones that are not applicable. Type 6 right here is I put a strike-through there. That is not even supported by Cisco routers. I believe that's multicasting for OSPF. Type 8 is also not supported by Cisco routers, and then types 9 through 11, which I believe are reserved, and I believe that is, I can't even remember, but nonetheless, it's not on the CCNP exam, so we don't need to cover that. We just need to worry about types 1 through 5, which are on the CCNA exam, I believe. Yeah, it's on the CCNA exam. Those are the most common ones. Then there's also type 7, which is added, which we need to know about for the CCNP route exam. So we're going to break these down one by one, and we're going to fire up GNS3 and see what they look like. As you can see here, there's type 1, the link state ID, that is identified by the router ID of a router. You'll see. We'll run GNS3. We just need to run show IP OSPF database. That is the command to see these LSA types. LSA type 1 is called a router LSA. Simple enough. Each router creates one for itself. As you can see, it floods it into the area. So we got router 2. He creates a type 1 LSA, floods it in the area, so on and so forth. But they stay within the area. They stay within the area. As you can see here, flooded only within the area. It includes information about its attached links. So in other words, let's say this ABR router right here, he creates an LSA. He's going to, let's say he sends router 2 an LSA. He's going to have information about this interface, and also that interface, which is about area 1. However, it's just going to stay within this area. He's not going to, he will send an LSA to router 3, but it's not going to have information. It'll have information about these 2 interfaces, but this LSA will stay within this area. Type 2 LSA is called a network LSA. As you can see, it's generated by the DR. What's the DR? No, it's not a Docker. It's a designated router. That's, again, the router. If you don't know what that is, I believe that's about 2 videos back. You'll know what a designated router is. Designated router is the router that is the one that handles the link state database, or LSDB. That is a database that has all the OSPF routes and keeps and stays updated, and he synchronizes it with everybody else. Those are everybody else's. So in other words, he is the DR. Everybody else are called DR others, or Drother, sometimes you can call it. There's also a BDR somewhere in there. This topology, we don't have one. A BDR is, you can guess it, a backup designated router. So when he goes down, I'm getting off topic here. Either way, the Type 2 network LSAs are created by the DR. He floods it into the area. This represents the subnet and connected interfaces, and flooded, the same thing, flooded within the area. The only difference between the two is this is generated on multi-access networks, right? And it stays within this area. So this Type 2 LSA, it says here, I know about routers A, B, and C, and he floods it within the area. He is not given a Type 2 LSA. The designated router will be given the Type 2 LSAs. That's the difference, right? So he can create a Type 1. He can create a Type 1 LSA, but router A is not going to create a Type 2 LSA because those why? Those are generated by the DR. Type 3 LSA is a network summary LSA. They don't summarize. They just call it a network summary because it gives you information about the Type 1 and Type 2 LSAs. As you can see here, it says summarizes info from Type 1 and Type 2 LSA. It's created by ABRs. What's an ABR? It's an area border router. It's like this. Router 2 is an ABR. Router 3, as you can see, is an ABR. They border areas. So router 3 borders area 0 and area 2. Router 2 borders area 0 and area 1. So he is an ABR. They create the Type 3 LSAs, which are advertised into the next, like the adjacent areas, as you can see, as it says here, flooded into adjacent areas. It consists of each subnet and the cost to reach it. So how does router 4 know about area 1? Well, he gets that information from a Type 3 LSA, which summarizes the info from Type 1s don't go into other areas, right? So in other words, so in order for router 4 to get information about area 1, he needs to receive a Type 3 LSA. That's the purpose of these. When you do a show IP route, you'll see OIA right next to the route. We may generate, I'll fire up GNS3. We may take a look at some of those. So again, Type 1s don't go into other areas. So in order for these other routers to learn about these areas, or areas that it's not attached to, everybody connects to the backbone, right? So this guy area 2 connects to the backbone, area 1 connects to the backbone. The backbone is area 0. But since area 2 is not connected to area 1, the only way he'll get information, again, is through a Type 3 LSA. That's its purpose. Type 4 LSA is an ASBR summary LSA. These are generated, as you can see, by the ABR to advertise the route to an ASBR. What's an ASBR? An ASBR, we mentioned that a couple videos back. It's an autonomous system boundary router. It's basically a router that gives you information that is redistributed from another routing protocol. So in other words, this is OSPF, right? We've been talking about OSPF this past 5-10 minutes right now, right? However, we got this little guy right here sneaking into the network. He's an RIP router, right? He's got an RIP route. That's redistributed into OSPF area 2. But in order for it to get distributed to these other areas, the Type 4 LSA will give that information to these other routers. So and that's created by the ABRs. So remember, the internal routers can only create a Type 1 LSA, right? But he received it. He is actually an ASBR. Once he realizes, oh, I got some RIP routes. Let me send you a Type 1 LSA, but then in order for it to go to these other other areas, it has to turn into a Type 4 LSA. That's why it's called a summary ASBR LSA. It's flooded into the adjacent areas. Next, we got Type 5 LSAs, which is an AS external LSA. Similar to Type 4, however, these are created by ASBRs to advertise external routes. Type 4 provides reachability for the Type 5 routes. Type 5 is created by the ASBR, so like Nancy right here. Shout out to networklessons.com. That's where I got these graphics from. Again, networklessons.com. Check out that website. It's created by the ASBR to advertise external routes. What's an external route? It's a route that he learned from RIP. So it sounds like it's a Type 4. However, it's generated by the ASBR, flooded into these other areas, and then that's when he goes, oh, okay, I got an RIP route. Then he says he gets it. Oh, I got an RIP route, and hands it off. So the difference between these two is it just lets him know about the ASBR. Router 1 is the ASBR in this case. He floods his router LSA or type 1 LSA, and then he just floods these guys, let them know, hey, I know about this information about an ASBR. It doesn't give you the routes. See, it says here in the picture below, RIP routes are learned by Router 1. Router 1 would now identify himself as an ASBR, then hand this info off to Router 2 in the Type 1 LSA. Router 2 will let the other routers know about Router 1. So he just learns about the route. He just learned about these guys just learned about the ASBR, Router 1. And then Type 5 actually gives them the routes, right? That's why it says here AS, or Autonomous System, External LSA. Finally, Type 7 is a NSSA External LSA. NSSA is a not-so-stubby area. We haven't covered the OSPF area types yet. We'll do that, I believe, in the next video. These are created by the ASBRs inside an NSSA. So we're going to fire up GNS3. We're going to have to kind of change our area types to generate these different types of LSA. So in this one right here, OSPF Area 2 has now become an NSSA, not so stubby area. Again, we'll cover those area types in the next video. So this becomes an NSSA, and it's used instead of a Type 5 because why? Type 5s, as you can see here, Area 2 is an NSSA, which don't allow Type 5s, external Type 5s. So we have an external Type 5, right? Type 7. It becomes a Type 7 because this is an NSSA. It sounds like it's this, but it's not because this is now becoming an NSSA. So it sends a Type 7. Type 7s aren't allowed to go into other areas, so as you can see here. And Area 2 is an NSSA, which doesn't allow external LSAs. To overcome this issue, we're generating Type 7s LSAs, so our OSPF domain knows about the prefixes that are redistributed from RIP. So Type 7 gets flooded into this, and then it gets converted into a Type 5, as you can see. So let's go ahead and fire up GNS3. I know it seems that I heard that this is one of the hardest parts of the CCNP route exam is the LSA type. We're going to fire up GNS3 and kind of experiment with that. So this is the topology we are going to work with. While this is firing up right now, let's go ahead and discuss this. We have EIGRP 100. Yes, EIGRP, even though I know this is an OSPF video, but we need to do this to redistribute and talk about external autonomous systems. This right here is OSPF Area 1. We got 3 routers in that. Not necessarily 3 routers, but we have 3 routers that have interfaces in Area 1. Let's not get this confused. Routers aren't they're not declared in a specific area. It's their interfaces. So I always keep making that mistake when I'm explaining this stuff. So like, for example, router 2 is not in Area 1 and Area 0. He just has an interface right there. He has an interface in Area 0, and he has 2 interfaces in Area 1. That's how we talk about areas. Router 1 is in the backbone area, or Area 0. He has 2 interfaces in Area 0. We're not going to say router 1 is in Area 0. We're going to say, to be more specific, to be more technical, router 1 has 2 interfaces in Area 0. Router 5 has 1 interface in Area 0, 2 interfaces in Area 2. We got router 6 and router 7, both with single interfaces in Area 2 respectively. Now that those are fired up, let's go ahead and console into router 1. Take a look at a couple LSA types. Now the first 3 are really easy to generate. Again, because remember Type 1, LSA type 1s, they're generated by each router, right? So, and they stay within the area. So we're in router 1 right now, right? So let's go ahead and, actually router 1's right here. Let's go ahead and reconnect there. Let's go ahead and show IP OSPF database. That is how you look at link state advertisements. So this is type 1, type 2, and that's type 3 right off the bat. Right off the bat, running this command right here, we got a router link state, router link. That is basically a type 1 LSA. It's tongue twister here. Let's take a look at what type 1 is again. Again, each router creates one for itself and floods into the area. It's created by ABRs. It includes information about its attached links. What are his attached links? And it's flooded within the area, right? What are his attached links again? Router 1, he's got FA00 and FA10. How we see that information? let's just do show IP OSPF database. And we said that the link state ID for those are the router ID. So his router ID is quad 1. We're going to take that, and as you can see here, what are the options after that? We want to see the router link state, right? So we're going to say router, put in quad 1, my bad, quad 1. Take a look at that, and there is our link state advertisement. Link state age, 120 seconds. A lot of information here. Link state ID, all of the stuff that we said about what a type 1 LSA is. Moving on to type 2. Again, it's a network LSA. The link state ID is the interface IP of the designated router. So let's take a look at type 2 LSA. It's generated on multi-access networks, generated by the DR, represents the subnet and connected interfaces, and flooded within the area. So let's run that other command again, the same one right here. Running that again. So this is type 1, type 2, and that's type 3 right off the bat, right? So this is type 2. We could run, what is this, 12.12.12.2? I believe that is, okay, so the advertising router is 2.2. All the loopbacks are, they're the same thing as like their host name. So router 7 is quad 7, router 6 is 6.6.6, so on and so forth, right? So that means this is router 2. So router 2, I guess he must be the DR in this case, right? Let's take a look at router 2 then. We're not going to console in him. So we're saying router 2 is the DR, right? Let's make sure. Who is the DR? Let's do show IP OSPF just to see. We're just doing this little experimentation here, right? Designated router is, I believe it's show IP OSPF interface. FA00, show IP OSPF interface FA00. That should tell you the designated router is quad 2, just like we said, just like we mentioned. So this guy is the designated router, just like we said. So now back to router 1, we'll do show IP OSPF database. And again, we said this is a type 2 LSA. So let's get information about him. Take a look at him again. Again, that is router 2, right? But that's his link ID, because we said why? Link state IDs for type 2 LSAs is the interface IP of the DR. So let's take a look at that real quick. So IP OSPF database. What are our options again? We want to take a look at type 2 LSAs, which is a what? Network. So we're going to say network and put in the interface ID. Actually, let's see what he wants to know. The link state ID. See? Link state ID. So my bad. We said it was 12 dot something. We said it was this guy. Take a look at that, and that is the LSA Type 2. That's information on the LSA Type 2. What does the LSA Type 2 contain? Subnet and interface, connected interfaces flooded within only the area. So that's the Type 2 in LSA. I wish it would just say Type 2 LSA, but they say net link. So again, let's take a look at Type 3 again. So Type 3 here says it's a summary LSA. We said that Type 3s are network summary LSA, created by ABRs, consists of the subnet and cost to reach it, summarizes info from Type 1 and Type 2, flooded in adjacent areas. So we need to basically look at an ABR. Who is an ABR in this case? Router 2 is basically an ABR. Let's go ahead and console with him. Actually, we'll stay on router 1 and continue our investigation. This is we're going to look at Type 3. So link state ID, we've got 2. We got 23. We've got 2 not 2 DRs, but 2 area border routers. Who are they? This guy and this guy. What's the link state ID? No, actually, no. They're both the same. Sorry about that. As you can see, the advertising router is 2.2, quad 2. So basically, this is the area border router that we need to look at, that we're taking a look at here. So I'm not too sure why this is not an area border router, because it's bordering 2 areas here. But let's go ahead and take a look at information on that. This is the link state ID. We said Type 3 link state IDs are the router ID of the ASBR. So what's the router ID? What is the router ID of router 2? We said router ID is quad 2. So that's his router ID, really. So let's go ahead and do show IP OSPF. Actually, no. This is the link state ID. We don't want to do the router ID. Let's do that. Take a look at that. OSPF database. Actually, no. We do need to do quad 2 because we want to look at summary, right? So now we're going to do summary. Summary. Nope, that's not what we wanted. So let's do it by that IP address. That's the link. That's actually the link state ID. So let's do that. And there it is. That's the type 3 LSA, I believe. Correct me if I'm wrong, but I believe this is the type 3 LSA that we were looking at, that we were wanting to look at. Let's take a look at the type 4. This one will be a little tricky here. Type 4 says it's an ASBR summary. The link state ID is the router ID of the ASBR. We said that type 4s are, again, ASBR summary LSA. We said it's a ASBR summary LSA. It's generated by ABRs to advertise a route to an ASBR. So basically, we need to do some redistribution here. In other words, this one was a RIP router. He redistributed some RIP routes in here. And then router 1, as he knows about it, he's like, oh, I know about it. Hands off a type 1, which becomes a type 4 because type 1 stay within the area, right? That's how you generate a type 4. So let's take a look at that. Let's try to do that. We need to do some redistribution here first before we do that. Actually, yeah. So let's go ahead and go into router 3 and redistribute EIGRP routes. We're going to console in router 3. Console in the router 3. Let's do show IP EIGRP 100. What am I doing? Show IP EIGRP neighbors. We do have a neighbor. Let's do some redistribution here. Router OSPF 1. Redistribute EIGRP 100. We're going to do, it says only classful, so we need to do the subnets. Get out of this. So we are redistributing some OSPF. So now we are redistributing EIGRP into here. Router 3 should generate a type 1. And then type 1 stay within the area. So in order for these guys to know about it, it has to turn into a type 4. That's basically what's happening here. So we're going to go back to router 1 and see if we generated a type 4 here. We're going to go back to router 1. Show IP OSPF database. Actually, yeah, there it is right there. Summary ASB. We also generated a type 5, actually. So we got this. Here's our type 4 LSA. This is our type 5. I wish they all said what they were. Like this says type 5 right here. I don't know why they did that. Maybe for exam purposes. Who knows? But this is summary. Let's take a look at that. We said the link state IDs for summary ASBs are, link state IDs are router ID of the ASBR. And for the type 5s, it's the network address. So let's take a look at the router ID for link state ID for type 4. Let's break down the type 4 LSA. We're going to do show IP OSPF database. We want to take a look at a type 4, and type 4 is also known as a what? ASBR summary. Yeah, type 4 is an ASBR summary, and then the link state ID is a router ID of the ASBR. Who is the ASBR? It's the advertising router, basically. So the advertising router was quad 2. Or quad 3, rather. No, it's quad. Yeah, quad 2. It says here link state ID is 3.3, so that's what it should be. That's the link ID. That's what we need to put. And there it is. I believe this is our type 4 LSA. So you can see here, type 4 again is generated by ABRs to advertise routes into an ASBR. ABRs created one per area, flooded into adjacent areas. So the flood type 4 goes in here. So notice type 1 goes in here, and type 1 stay in the area. So in order for these guys to know about the RIP routes, it has to be turned into a type 4. That's the summary. It doesn't give them the routes though. It doesn't give them the routes. It just lets you know Because see, look, let's see if we know about these routes. I don't think we do. Maybe we can have a RIP route. Yeah, we do actually. Let's move along to, we did a type 4. We also did a type 5 that we just looked at. Type 5 is an AS external LSA, which we just created. It's created by ASBRs. And that's how we were able to get that's, I believe, how we were able to get the routes. So yeah, that's how we were able to get the routes, because it was the type 5 LSAs. If we want to know about the type 5 LSAs, here's how we break those down. We do show IP OSPF database. What's a type 5? We said a type 5 is a AS external LSA, LSA. So it would be not the ASBR summary. It's not the advertising router. Not too sure which one that would be. That's y'all pop quiz for today. How do we get more information about the type 5 LSA, which is the AS external LSA? So what's the, well, first of all, what's the link state ID? That's how we can figure it out. It's the network address. It's the network address. So what's the network address of that we're trying to get? That right there. Remember? Because it was the EIGRP route, right? Because I believe it's router 8. Let's verify that though before we wrap this up. We got router type 7s after this. Yeah, because it's the EIGRP, I believe. That's the network address. Let's look at the router 8. Let's console on the router 8 and see what he got here. We're going to console on the router 8 just to be sure. Yep, it's the EIGRP route. So show IP interface brief, exclude unassigned. Yeah, that 38 network is what we were trying to get. So that's the link state ID for type 5s. And database, no, my bad. That's the link state ID. So let's just say, not network. It's not self-originate. Summary of database. Let's say external link state. External link state. That's not it. That's not it. That's y'all pop quiz for today. How do we get information about that type 5? I mean, we got the information about the type 5 like this. Oh, there it is right there, right? Yeah, that's the link state ID. We did that. We did that. Maybe that's what we need to do. Network external, and then that is the network. That is probably it right there. Type 5 link state. That's what we was looking for. Perfect. That's how we broke it down. So now let's go ahead and move on to type 7 and wrap this up. We said type 7 is NSSA, external LSA. So basically we need to turn one of these, we need to turn an area into an NSSA area and then generate those LSAs. So notice NSSA area here. These type of LSAs cannot go into these other areas. So if this becomes an NSSA area, the type 7 LSAs will be generated. They're only flooded within the same area. So in order for these guys to get information about this area, we need to create a type 5. So notice it says type 7 that's flooded in the area. Once it gets to the ABR, they're generated by ASBRs rather, ABRs. The ABR will convert them into type 5 LSAs, and that's how they learn about the external routes. So let's go ahead and we're going to convert this area into an NSSA. So first of all, we need to go to router 3. Actually, we're already in router 2, so let's go ahead and do that. We're going to do router. We need to do these interfaces NSSA. So we're going to go to router 2. Let's start off with, since router 3 is already powered on, we're going to go into his OSPF 1 area 1 NSSA, and that's all we're going to do there. We're going to copy this and put it on all the interfaces. Notice OSPF just bounced, so we need to do that on the I believe we need to do it. No, we just need to do it on the process. So router 3 we just did it on. Let's go ahead and do it on 2 and 4. Router 2. Configure terminal, router OSPF 1. And router 4 will do the same thing. Configure terminal, router, OSPF 1. We turn this whole area into an NSSA. So these should generate type 7 LSAs. Let's go ahead and check. Let's go to router 2 and see if we got some type 7 LSSAs, or LSAs rather. Tongue twister there. Show IP OSPF database. There's our type 7 LSAs, right? So there's our type 7, and type 7s can't go into this area, so you're not going to see a type 7, and theoretically we should not see type 7s in the area 0. So let's check anyway. Show IP OSPF database. We got our type 1, type 2, type 3, type 5. No type 7s. So the type 7s stay in here, and then they get turned into type 5s. Just like this, type 7s stay within the NSSA area. Once they get to the ABR, they get generated into type 5s, type 5 LSAs. That's all I got for y'all today. My phone died, so I can't give y'all no sound effects. That is my YouTube page. That is my Twitter handle. It is hot and humid out here. Please go ahead and add me on Twitter. Please share this on your social networks, Facebook. Anybody that's trying to get into networking, let them know this is how I teach, and it's just my way of teaching. And you know, if somebody likes different perspective, show them these videos. For now, please comment, like, subscribe to the network, bro.